Where I am working. Okay, I'm working in Colab. I forgot. Okay, so this is the data clean 3. This is your data, right? And now here you can see there is the ozone, solar, wind, day, temperature, weather. These are the things available. In weather, that is the category type of the data. So how to deal with this category type of the data? All are, you can see the ozone, solar, wind, all are the numerical data. And if numerical data, then you can easily deal with the numerical data, because obviously the machine learning and whatever the thing means, this computer can deal with the only, you can say, a numerical data. So we need to convert this weather also in the numerical format. Okay, so how you can convert? Can I write 1 2 3 4 instead of S C P S S? Here three category na, the 1 2 3 can I write? No, you can't write, because that actually indicates the magnitude 1 2 3. Instead of writing as, I need to convert this weather column into the numerical format. So what is the way to convert into the numerical format? Then only I can analyze now. Otherwise, I'm not getting any value. You can see in the our previous analysis also. Here I'm getting none, none. Okay, here is okay. But also, what is the name? This weather, that I'm not getting, because that is a category data. I'm not getting any analysis for the category data. So what I need to do? I need to convert this particular part into the numerical format. How you can convert? Is there any idea? This particular thing is also known as a one hot decoding. Okay, so you can do that particular thing also. It how to do? Let I try to do here. So what is your data? Suppose I take this particular data as a data C4 and data C5. Take data C5. Okay, and data C5. What you need to do? PD means that is a pandas library. Already I called pandas as a PD. So pandas library, and there get dummy you need to write. Okay, get underscore dummies. Okay, get underscore dummies. And now what you need to do? What column you want to? Okay, what is your data? Just pass the data. So data, in my case, data clean 3. Data, I think underscore. Data clean 4, clean 3. Okay, I take the data clean 3. And now this is my data, and what I need to do now, which column you need to pass, means which column you want to change in the form of the dummy. Okay, so columns is equal to, write down your column. What is the column name? Weather. So write down the weather. I think W is capital in the weather. Okay, so now this is your new data, that is the data C5. And okay, let me check what is the thing is, means we getting as a output. Okay, so data C5 I just put and call. Now you can see it, the your particular weather is now converted into the three section: weather C, weather PS, and weather S. These are the three category actually available inside the weather. And now you can see, okay, means now all the thing is converted into the numerical format. Okay, so this is also part, means once means you will get the some category type of the data. So how to handle the category data? By use of the one hot decoding, or you can say by use of the dummy columns, you can easily convert. Okay, I can't write 1 2 3 4 because that magnitude is different. Okay, so you need to do this type of the thing. Acha, code na one. Next, normalization. Okay, so why it is necessary? Why we need to do the normalization? Anyone who can suggest? Normalization, why we need it? Sometime in the data, like we go through the our previous data na, there you can see the professor related data of one university, and there what is the column is available, services provided means they given the services in the form of the year, or you can say in the their unit is the year. So they provided like as 3 year, 4 year, 5 year, like that, in that column the number of PhD pass out students. So there they given the 2, 3, 4, like that value. Okay, and when I talk about the salary there actually they mention like the 50,000, 1 lakh, whatever the 2 lakh and 1.5. Now you can see the variation. There is a large variation when I compare the service, PhD, number of PhD pass out and the salary column. There is a large variation is present. So you need to that all the thing you need to do the normalize means you need to reduce the scale. Normalization is nothing but what is the thing, x means that is your actual variable minus x minimum divided by x max minus x minimum, that is a formula. Okay, so that convert in everything into the smaller scale, means we will convert that particular thing means our data, and let's see how we can easily means convert entire thing into the smaller variation, or you can say into the smaller scale, how we can put entire thing into the smaller scale. So it will not means give any error regarding to the scaling. Okay, because that is one is the very large. So sometime if we plot the graph, that time also you can see we are unable to visualize the data properly because of this variation into the data set, means there you can say one data there large value present and one data there is small value present, due to that we unable to visualize sometime. Okay, so now in the normalization what you need to do, for that where is there is for entire machine learning actually one library is used, that is the pip install scalar. So sklearn actually library is after this particular means once we complete the syllabus explore this sklearn na, because the entire thing start the machine learning start with this sklearn. Okay, so now in sklearn what you need to do, you need to install like pip install, that may be means already available in my system means in this, but okay, pip is install sklearn, that is the one library available. Okay, so it will take some time, it will install entire thing whatever that is needed. Now successfully install scalar, you will get the output. Okay, now for normalizing the data what you need to do, uh, normalizing of the data. Okay, that is the normalizing of the data, maybe my spelling will be wrong. Okay, so in normalizing of the data what you need to do, you need to import from scalar. Okay, from scalar import pre-processing, because these are the pre-processing part. Okay, normalizing standard scale, that are the pre-processing before the machine learning. So you need to import the pre-processing. Okay, so now what you need to do, this is done, pre-processing is done. Now you need to normalize the data. Okay, so I run first this particular line, run is complete, then we can go for the next. Okay, one. Hmm. So now normalizing, how to do the normalizing. Okay, so what you need to write now, pre-processing, that is just we imported. Okay, the pre-processing. Okay, in pre-processing what you need to take, normalize. So write normalize. Okay, in pre-processing normalize, pass your data, just pass your data. What is the my last data C5, right? Pass the data, you will get the output, and you are not getting the output because some none value is present. It shows actually I removed all none value. But if you getting this type of the error, then what you need to do, normalizing means it is deal with the numerical value. So if getting the none value, none means you will get the error na, in that case. So what you can write here, even you can write here drop na, then it will work. Now no, the data is normalized, means entire data set is normalized, but you will get in the form of what you can say, in the form of this particular thing in the form of the array. So you need to convert this data into the data frame, right? Then you can see into the tabular format, right? So what you need to do, already we discussed, for convert into the data frame, what you need to write pd dot data frame, then you can convert. Now your data into the tabular format. But I am getting here 0, 1, 2, 3, 4, 5 and 9. I need to change this particular thing. Okay. So what you will be do? I will add one more code here. What is the data C5, right? Data C5. If I see the data C5, there all the column name is present. All the column name is present. 1 minute. Now what I will take here, columns. So it will show me the only column. This is the column name, right? And I want to pass this particular column name inside my new table, that is the normalized table. So what I will be do here, this I can take as a names of the column or any variable you can take. So this is the one variable that I need to consider, and that I want to pass, where I want to pass this particular thing, I want to pass in this in my data frame. Okay, so I will pass, this is my data, this is my data, right? This entire thing is my data. You can assign as a one variable also. Now here I will pass the column. So how to pass that, I think we already discussed, but I will again mention column is equal to names. Now you can see the names also. Name is present, and all data is normalized now. Now you can see every data has a value between 0 to 1, and it is in the range. It is in the range, in the uniform format, you can say. Any doubt? 1 minute. So this is your normalized data, and you can see the normalized data by use of, and you can call, this is the norm data, and now I can call, and I can run also. So this is normalized data. Okay. So now the next point, we can convert the data into the standard scalar also. So normalized data is nothing but x minus x, I think x max divided by x max minus x min. That is the formula, and you will get all the thing into the uniform format. Now I want all the value in the form of the z score. Okay, z score is nothing but the standard scalar, you can say, and that also you can do what there again, that function of the scalar. Okay, so what you need to do, from scalar, okay, pre-processing, scalar pre-processing, import standard scalar. Okay, so this import you need to import, then you can convert your data into the standard scalar. Okay, so how to convert into the standard scalar, there you need to type standard scalar. This is my actually import na, so I will take this one. This is the standard scalar. Yeah. Hmm. Okay, I will type standard. So standard scalar and dot. This is the actually function. Okay, so use the function dot fit transform fit underscore transform. You will get the suggestion also. And now pass your data. So what is the data? In my case, that is the data C5. Okay, so I will take the data C5, and now invalid double dot actually I use. 1 minute. I'm sorry. Bad. Now it will work. Okay, so you converted entire thing into the standard scale, and this is in the form of, you can say, in the form of, right now this entire thing in the form of num means array, and you can convert into the table by use of the pd dot data frame. Okay, so I will use the pd dot data frame. Even I try to write the entire thing into the one. Okay, so this is my variable, this is entire thing is the my variable. Okay, and that I want to convert into the data frame. So what I need to write here, pd dot data frame, and this is my variable I pass. Column name you want, yes, column name I want. So columns is equal to, what is the names that already I mentioned earlier. Now you will get the table. This is the table, there none value is also present and entire thing. Okay, but this is your table. Okay, and this is the on the basis of a standard scale. Standard scale means this is the z value for each. Okay, z means z is equal to x minus mu divided by sigma, that you can see. And now it will help to see there are lot of outlier present, then also you can visualize, means above 2 and above 3 are the outlier, you can say like that, right? Z is equal to minus, means it is less than minus 2, then you can consider as an outlier, because we know that in the normal distribution, if I quickly draw the one graph, then you will understand when I talk about the normal distribution. So this is my normal distribution graph, and when I say here minus 2z, and here if I say plus 2z, there my 95% value should be present, right? Another I will consider as an outlier. So if more than 2 minus 2 and more less than minus 2 and more than 2 value present, then you can consider that is the outlier, and that is your work as a homework you need to do. You need to remove the outlier on the basis of that already we done, but you can see, because already we made a one function and we already remove the outlier, that part already done. Okay, now so you can go through the previous session, then you can see, okay, there that part is covered. Okay, now quickly we go for the normalization is done. Okay, so why we need to use all these things, you will understand when you go deep into the machine learning part. There you will understand, because there are a lot of difficulty you will face. Sometimes one value is very large and one is very small, so you can convert into the standard scale or you can convert into the normal scale, and after that if you do the analysis, it will take less time for your means your computer also will take less time, as well as it will give the good accuracy. Both the thing is there. Okay, now this part is completed. Now sometime maybe you want to see, okay, I want to speed up this entire process, I don't want to do into the small step, I want to do entire thing in the one line of the code, then also you can do. Okay, so that part we will discuss now. So now the next I can say the speed up of the EDA process. Okay, speed up EDA process. It may be sometime give you the error, but the two library is present, and that actually very useful for the you can say for the EDA. Okay, you can do by use of this two library, by one line of the code you can do the entire your exploratory data analytical part. Okay, so that we will discuss. And this is means why we, even if I can show that particular part early also, but if I show early one line of the code and entire thing if I do, then you may be not interested in this part, and if you don't know the actual concept, then it will not helpful. Okay, so concept is required when you can use this type of the thing also in the industry, but concept you should know, okay, how actually all this thing is working. So that's why I discuss all the thing in the small segment. Now, okay, so there is the one library, that is a pip install pandas profiling. This is the actually big library. It will take time, and even you can take this version equal to you can write the version also sometime. Okay, so 3.1.0 also you can install. So this installation will take some time. Library I install two library. One is the this one, pandas profiling. Okay, so pip install panda profiling, and you can take any version. The next one is the pip install SweetWiz, and after that import SweetWiz as a SV. And one more library I will take, that is the import pandas profiling as a PP. Can I write PP? So it will means when again I need to call, it will be easy, right? So what I will be write, import pandas profiling. Both are the different, na? Means SweetWiz and panda profiling both are the different thing. So import pandas profiling as a PP. Anything you can write. Okay, so now I want to make this report. Okay, so what you need to do, PP means panda profiling. Okay, and now what I would need to write, profile report. There in the profile and the report, P and R is capital. Okay, profile report, and there pass your data. So I take initial data. Okay, means initially I getting this data na. So I will take that, not clean and all data. Whatever the original data you are getting without clean, that I will pass. That data. Okay. Now run this particular and assign this as a one variable, because it will take some time. Okay. So assign as a one variable EDA report you can take, assign as a one variable, and now run. So this is means assign as a one variable. Now what I need to do, I need to generate the EDA report. Okay, so what I just written the name is the EDA report, right? That is my variable, and that I want to save. So to underscore file, and I want to save this as a output file. I will write here output file. Okay, in output file you can write the name, any name. So I will write EDA report by PP is panda, and .html I can write, because I want to create in HTML format. Okay, and generally this type of the report will create in the HTML format. Now you can see entire report will be generated. Okay, it will take some time, but entire report you will get. So this report is generated. I will download, and now you can see where it is. uh, 1 minute. So I save. Now you can see this is the EDA report, and this report will tell you entire thing. Now in this report you can see many things, like number of variable, number of observation, how much missing cell in the form of the percentage that is given, duplicate row, all the thing you can see, the numerical, categorical, alert also given, means it shows that year has a constant value. When you go through the year wala column na, you will see there 2010 present in the entire column. So that is not that much useful for the analysis, right? You can drop, because in every in the year column all value are 2010. So that is not useful, right? As well as you can see the index is highly correlated. On the basis of the this high correlation you can drop some feature, so there also it will be useful. when you click on the reproduction, you can see the each variable what is the missing value and all thing, as well as the it is the normal distributed or not. When you click on this toggle detail, you will get again more detail about the each variable. Okay, so if I click here, now you can see, you go down, you can see more detail. 1 minute, I click. Now you can see the entire stats part. Entire stats means what is the fifth percentile, what is the q1, median, q3. For each column you can see, as well as the histogram you can see, it is normal distributed or not, as well as the common value you can see, as well as the extreme value also you can see. Now maximum 5 value also you can see, minimum 5 value also you can see, many thing you can see. Okay, so this entire thing for the each variable you can easily see, even the 100 variable, then also you can see. The next interaction you can see, like okay, is the temperature and temperature C, if I want to see, both are the duplicates, we know, right? So that's why we drop one thing. So now here you can see, you will get exact straight line. It means both are same. When I put the temperature C value, exact value I am getting the temperature, so it is the same, and you can remove that. Okay, so like that you can see the interrelationship between any variable by just one click. Okay, solar and wind, that also you can see, temperature and ozone. So is there any correlation that you can easily identify by use of this data visualization? Okay, the day and solar means you can see, is there any relation? So there is no proper relation, you can see all are scattered and not following the straight line. But wind and ozone, if I take it again, you can say when the wind is it is a downward, means you can say the negative correlation between the ozone and wind, means when the ozone is increased, the wind is decreased, like that you can make some conclusion. So it shows the correlation, as well as it will show the Spearman correlation, Pearson correlation. I think you are aware about that, right? Pearson correlation means it's nothing but the CR, means that value means what we x minus x bar, y minus y bar divided by sigma x sigma y. So that is the Pearson correlation we just discussed. And when we talk about the Spearman, it convert entire data in the form of the rank, and after that on the rank basis you need to calculate the covariance. So that is Spearman correlation, and many thing is present. Okay, even you may be not aware on something. Okay, in the Pearson, when I click again toggle correlation, you can see the detail about this entire graph. Detail also you can see. When you go down, missing value you will identify, count you will identify, matrix you will identify. Here you can see how many missing value. No need to make this heat map and all thing, you can directly see by just one line of the code, you can see the entire thing. This is that dendrograph, actually it is used for making the cluster, but that is not your means right now, means we discuss, because that is not covered. But many thing you will get, see, entire thing you will get by just one line of the code. Okay, and it is useful na? Okay, and if you're not able to run, then again go to and do in the collab, you will get the report. Okay, now quickly we will do this part. What is the second? That is the EDA. Okay, so for no, that is for suite views. So how we can utilize the suite views for the making the report. Okay, so one more report we will make, then I will give you the break. Okay, so now we suite views, we use the SV as a alias, right? Already we use, हो जाएगा लास्ट है, एक लाइन का कोड है, SV dot analyze, okay, and they pass your data. Now I want to save this data. Okay, so how you need to save the data? You need to write the suite underscore report, okay, dot show html, show underscore html. Now pass the name, whatever the name you want. So I just write the weather underscore report dot html. Now you will get the report. 1 minute. Sweet report is not defined. Huh? 1 minute. 1 minute. This one actually not defined means I need to define this thing. Na? 1 minute. What you need to do? This is actually sweet report that I need to assign here. This report. Na? This is actually report. So I need to assign as a one variable. And after that, if I run, then I will get. It will take some time. Done. Now you can go for the next. Now your report is generated. You can see the report here. That is the weather report. You can download. Downloading done. Save. Now you can see your weather report. So here weather report. Again, this library also much is useful. When you click here, you can see the graph. When you click association, you will get this correlation graph. Okay, as well as the description is the given. So this entire thing will be helpful. By one line of the code, you can see the entire data related thing. Okay, entire thing you can see. But I suggest the Panda profiling is much more better than the SweetWiz. Okay, so by Pandas profiling, by one line of the code, you can do the entire. So this is all about the quick EDA. You can say, yeah, how to speed up the EDA process. Okay, so we conclude here this part.